السلام عليكم ورحمة الله وبركاته. We are students in Taiba University. We will talk about friction. We are Mundir Saadi and Talal Al-Harbi. We will give you introduction and two examples about friction in static. This project is sponsored by Dr. Sultan Salama. Let's start. In the preceding chapters, we have usually assumed that the forces of the action and reaction between contacting surface act normal to the surface. The assumption characterizes in reaction between smooth surface. And there are many problems in which we must consider the ability of contacting surfaces to support tangential as with normal forces. Tangential forces generated between contacting surfaces are called friction forces. That's we need friction forces. Okay guys, after the introduction I will talk about the types of friction. The first type is dry friction. Dry friction is the most important type in friction in this video. Dry friction occurs when the lubricated surfaces of two solids are in a contact under a condition of sliding or a tendency to slide. And the second type is fluid friction. Fluid friction occurs when adjacent layers in a fluid, liquid or gas, are moving at different velocity. And the last type in friction is internal friction. Internal friction occurs in all solid materials which are subjected to cyclical loading. Now I will explain to you the static friction and the kinetic friction. I will start with static friction. Maximum value of static friction F max is proportional to the normal force N. Thus we may write F max equal mu S multiplied to the normal force N. As for kinetic friction, after slippage occurs, a condition of kinetic friction accompanies the in-swing motion. Kinetic friction force is usually less than the maximum static friction force. The kinetic friction force, Fk, is always proportional to the normal force. Thus, Fk equal mu k multiplied to the normal force, N. Okay, let us start the examples. The first example, if the coefficient of static friction between the crate and the surface is mu s, determine the maximum angle theta before sliding happens. In this example, let us assume the taping over does not happen first. Okay guys, in this problem, we don't know the weight of crate and we don't know the dimension either. We will start solving this problem by sketching the free body diagram of this crate as shown in the figure. The weight force W acting at the gravitation center at this object. And we have the normal force N. It's perpendicular to the object. And lastly, because the object will sliding down, the static friction will be opposite to the motion. Now we will complete the free body diagram. So we have the equilibrium force. Sigma Fx equal W multiplied sine theta minus Fs equal 0. And sigma Fy equal minus W multiplied cosine theta plus N equal 0. And the static friction law is Fs equal mu s multiply N. Okay, from the first equation we will say Fs equal W multiply sine theta. And from the second equation we will say that N equal W multiply cosine theta. Okay, we will back to the law of static friction. Mu s equal Fs per N. That is equal W multiply sine theta per W multiply cosine theta, that's equal exactly tan theta. So mu s equal tan theta. But the maximum theta will equal tan inverse multiply mu s.
I will explain example 2. The two uniform boxes, each with weight 200 pounds, are simply stacked as shown. If the coefficient of static friction between boxes is mu s equal to 0.8 and between the box and floor is mu s equal to 0.5, determine the minimum force P to cause motion. They are have same weight and same dimension, simply stacked together one on another as shown in figure. Okay, we need to think about how many possible motion are there. First, there are 4 possible motion. First, the top box moves only if it slides on the bottom box, but the bottom box stays static. Second, top box dives over into the bottom box against a static. Third, both boxes slide together. Lastly, both boxes dive over together. Okay, let's start with first situation, which is top box slides only. First of all, draw free body diagram as shown in the figure and do two equilibrium equations, which is sigma fx equal to b minus fx equal to 0 and sigma fy equal to minus 200 pounds plus normal force equal to 0 and friction's law, which is if it's equal to mu x multiplied by normal force, and if it's equal to 0.8 multiplied by 200 pounds equal to 160, which is P force. Okay, second situations when top box types over. First, draw free body diagram like this figure. But now the location of force or normal force is important because we know that for typing over, to having the normal force must be placed at the edge of this box, 1.5 feet away from the center, as shown in the figure. Then, in these situations, the two equilibrium equation force are less useful because friction force doesn't necessarily to equal to mu h multiplied by n because it's applied when slipping. We use moment about point A as equal to minus b dot 1 feet plus 200 pound dot 1.5 feet equal to 0. Then the third situations when both boxes slide together. Okay, third situation is similar to first situations except that take both axes are considered as one system. Then draw free body diagram. Friction forces having between box and the floor. 3 do equilibrium equations, which is sigma fx equal to b minus friction force equal to 0 and sigma fy equal to minus 400 pound plus normal force equal to 0. If s or friction s equal to mu s multiplied by normal force, if s equal to p force, which is 200 pound. Okay, then the last situations when both boxes type over together by make two bodies as one system at normal force at the edge as we discussed, as shown in the figure. Take equilibrium moment about point B equal to minus B multiplied by 5 feet plus 400 pounds multiplied by 1.5 feet equal to 0, then point force equal to 120 pounds. Okay, guys, now we summarize the scenarios. One, if top box slides only, required force equal to 160 pound. Then top box type over, required force equal to 300 pound. Then if both boxes slide together, required force equal to 200 pound. Last, if both boxes type over together, required force equal to 120 pounds. The last case is the answer, which is minimum value.